welcome everybody to our presentation of our project developing a recommended system for grocery shopping in Berlin. Why did we do this project? We wanted to offer English-speaking foreigners in Berlin an easier way to find their grocery products that they needed, basically considering the price and availability of the products that they need in different stores. Our project consisted of 8 weeks, and below you can see the time frame of each of our tasks.
Firstly, with the wonderful team, we scrape the data from various store websites that are available in Berlin. Secondly, since we were having very less product information, we had to rescrape most of the websites. I consider this to be the most challenging part of this task. And finally, from a learning perspective, we realized that deciding on what features need to be scraped at the earliest is very crucial. Next.
The scrape data was very messy. It appeared in different languages and was large in size. The main challenge of data pre-processing was cleaning the data like special characters, handling missing values, and feature engineering. In this task, we learned that careful and systematic pre-processing is necessary to derive valuable insights from the data. This also enhances the performance of model and improves the interpretability. The next stage is exploratory data analysis. Here we analyze the large data set using univariate, bivariate, and multivariate analysis with visualization. The visualization of large and complex data set was very complicated, and so the relevant pattern identification was very complicated. From this visualization, we have seen that there is again scope of pre-processing like handling outliers and feature engineering. So we processed the data with necessary action and prepared the final data.
Due to the nature of our data, we pursued building a content-based recommender. Such a system recommends items to users based on similarities to items they have already rated or interacted with. For this, we imported the data and used feature engineering to clean the data, build new features, merge features together, and use various vectorization techniques to transform text into numerical data. As a final step, we use cosine similarities to build a list of top recommendations based on user search input.
For our project, we have to consider some limitations when we were choosing our evaluation metrics. Due to time limitation, collecting user data, implicit or explicit feedback were not feasible. We chose hit rate as our metric and adjusted it to our case and use. Hit rate gives us the percentage of relevant items returned by each query to evaluate our performance.
So after evaluating our models, now it's time for deployment. Deployment refers to the process of making a trained machine learning model available for use in a production environment or real-world applications. We deployed our model in Streamlight, which is an open source Python library used for building interactive web applications. Here is one of our deployed models. Here, user can enter a search query, for example, dark chocolate, and he can filter by any category. He can choose any specific store and filter by it as well. And then he can press search. Here are all the recommended products by our models. As you can see, all is related to his enter search query, which is dark chocolate. If he wants to access any of these products, he can press on this link, which will automatically transfer him to the product link as well.
This project would have not been possible without all the collaboration and active participation of all of our collaborators. Here is just a list of all of them that participated during these 8 weeks. Congratulations, because this has been an amazing learning opportunity. Thank you so much.